12, factoring part 2. There's going to be a bonus question like this on your quiz, and you might see one or two of these on your test next week. So it's an extension because you haven't factored cubic functions before, but it's the same process that you just used for quadratics. So we're just going to be factoring these by grouping, or you could throw all 4 of them into the box, and you could also do it using the box. So I'll do part A, and then you try part B. We're not solving this one, we're just factoring it. So you group together the first 2 terms. If there's a minus sign, it needs to go in the parenthesis with the second group of terms. So that negative 16 goes with that x. So then you look at the first set of parentheses. What could I pull out as a greatest common factor? I could pull out an x squared from each of those terms. So I write my x squared greatest common factor down. Then I divide each term by x squared. So I would have x minus 3 left. And then I do the same thing from the second set of terms. These are a little bit bigger numbers, and I have to decide if I want to pull out the negative 16 or a positive 16. So what I like to do is look ahead. I know that I have to create x minus 3 as my other parenthesis so that they match. What do I need to pull out as a greatest common factor to make it x minus 3? So what should I divide this second group by so that when I take out the greatest common factor, I'll have x minus 3 left up here? Right, so sometimes looking ahead to what you need will help you figure out what the greatest common factor is. So both of those are divisible by negative 16, and that will give me x minus 3. So now there is an x minus 3 in both places, so I can pull out the x minus 3's, and then what would I have left? X squared minus 16. So you're almost finished, but you always need to check. If you have a quadratic, you need to decide, is this prime or could this be factored one step further? So what do you think? X squared minus 16, is it prime or can it go further? It can go further because it's a difference of squares, right? So this actually can factor into x minus 3, and then x plus 4, x minus 4 is the pattern for difference of squares. So it actually has 3 separate factors. Not all cubic functions will, but a lot of the ones I give you will. All right, you're going to try part B the same way. Do part B with grouping. Did you get 2x minus 5 from both of them and then just x squared plus 1? X squared plus 1 can't go any further. It's prime because it's the sum of 2 squares. Even if you really wanted to factor it as x plus 1, this doesn't have a 2x as a middle term, so it's not x plus 1. So that's factoring a cubic by grouping. The other one is called factoring using the sum and difference of cubes. These are 2 formulas. I really put them out there to you just so you know they exist. And I would always give you these formulas. You wouldn't have to memorize these. So if this is on a test, a quiz, I will give you these formulas throughout this whole year. But I want you to know that you can factor the sum and the difference of cubes, unlike the squares. You can only do difference of squares. So I want you to know that if you see the sum of 2 cubes or the difference of 2 cubes, there's a way to factor that, even if you have to look up the factoring strategy. So this is just a formula. So if you notice what the formula is doing, you see this a cubed right here, all they're doing is taking the cube root of it to get a. So if you're starting with x cubed, now you're just down to x by itself. And then b cubed. So let's think of the perfect cubes. So 1 cubed is 1, because you probably haven't thought about cubes a lot. 2 cubed is 8, 2 times 2 times 2. We saw that on our parent functions. What's 3 cubed? 3 times 3 times 3. 27. What's 4 cubed? 4 times 4 times 4. That's an important cube to know for, we're going to study exponents later this year. Anyone know what 4 cubed is? Or do it in your head. 4 times 4 is 16. What's 16 times 4? 64. I think 5 cubed is one that you should recognize. 5 times 5 times 5 is what? 5 times 5 is 25 times 5. 125. And then I think 10 cubed is a nice one to recognize. I don't know myself without using a calculator, 6 cubed, 7 cubed, 8 cubed, but 10 cubed I know is 1,000. So if you notice, these are the numbers that are going to pop up in these problems. Is 6 cubed, is that 216 or 256? 6 cubed is 216. 256 is something though. Is that what 16 squared is? Yeah. So I don't know my sixes very well, but I'd have a calculator for that. All right, so this first one is the difference of cubes. So I'm going to go look at the difference of cubes formula, and it says write a minus b. So my first binomial is just going to be x minus 2, because I'm taking the cube root of each of those terms. Are you with me so far on how I just got that binomial? I took the cube root, I took the cube root. Once you have A and B, the formula is pretty easy because you already know what A and B are from this first parenthesis. So you're just going to square A. So x squared is just x squared, right? I square it. Then I follow the signs that are in this parenthesis over here. So it says write a plus sign. So you just put a plus sign in your answer. And then it says take your A and B values and just multiply them together, but ignore the sign because we already wrote a plus sign right here. So it's just 2x. 2 times x is 2x. So ignore the fact that it says -2 because the formula tells you that it's just plus. And then write another plus sign, says the formula, and then square your B value. So 2 squared is just 4. So you just factored a cubic function. Usually this trinomial won't be factorable again, so you'd either have to use the quadratic formula to figure out the other x-intercepts, but I know that one of my x-intercepts is at +2. So like I said, I'm not going to have you do the quadratic formula on the quiz, but this could factor, this might be just have solutions that are irrational, maybe it has no extra solutions. I'm not as worried about solving these as just factoring them. All right, so let's jump over here to part C because this is another difference of cubes, so we can follow the same pattern that we just did in part A. So I'm just exposing you to this today, and then we'll do some practice on these next week. But I just want to plant the seed that these are factoring strategies. So if I am going to take the cube root of each of these terms, what would I have? So I know from my little chart over here that the cube root of 64 is just 4. Right? And the cube root of 125 is just 5. So 4x minus 5 would be my binomial. I'm not going to be able to fit it. So times my trinomial. Now I just take these terms and apply this formula up here. So I have to do 4x times 4x. So that would be 16x squared is what that term is, a squared right there. And then a times b is just this term times this term with a plus sign, so plus 20x. And then I put another plus sign, and then I'm just squaring this 5, so 25. So 16x squared plus 20x plus 25 is my trinomial. So it's just a formula to show you that, hey, this can factor. And now the nice thing is I know that 5/4 is one of my x-intercepts on the graph. This may or may not have some other either factors or use the quadratic formula. All right, and then this last one is using the sum formula over here, a cubed plus b cubed. So my binomial, I need to take the cube root of both of these terms. So I know that the cube root of 1,000 is just 10. So I'd have 10x plus 1 this time. So if you notice, the first binomial matches the symbol of the original problem. So the sum of cubes, the first one's a sum, the difference of cubes, the first one's the difference. And then if you notice, it just alternates, and then the b squared is always positive. So this goes plus minus, and then this is always positive. The other one goes minus plus, and this one's always positive. So if you do these enough, you end up kind of memorizing the formula anyway, which will be good for calculus. All right, so now I'm going to take these two terms and throw those into this trinomial. So maybe you've already started to memorize. You just square the first term, right? So I'd have 100x squared. You alternate the sign. So if this was a plus, now I alternate this sign is going to be a minus. You multiply these two terms together. 1 times 10x is 10x. And then the last symbol is always a plus. So plus 1 squared, so plus 1. But you don't have to memorize those formulas. Just be able to use them. I think there may be one of those on tonight's homework. Anyone do homework 1-6 yet? So you might need to look up those formulas for tonight's homework. Okay, the last that I want to do with you, and then I'm going to save these practice questions on the back till next week. But this is called quadratic form, and these are quartic functions. So you might be like, oh my gosh, how am I going to ever factor quartic function? Well, it's called quadratic form for a reason. See how it jumps from x to the fourth to an x squared down to a constant? What you're going to do is represent it instead as a quadratic, x squared plus 4x plus 3, because this is an easily factorable quadratic using the diamond method, right? So using the diamond method, what are the factors of 3 that add up to 4? 3 and 1. So this would have normally factored into x plus 3, x plus 1. But this is a 4th degree polynomial. How can I make these set of factors work for this original problem? All you have to do is square the two x's. So if it's x squared times x squared, see how that jumps back to x to the 4th? What about your outer plus your inner? You'd have 1x squared plus 3x squared. That gives you 4x squared. And then see how 3 times 1 is still the constant 3? So it's a way to apply what you already know for quadratics to quartic level functions. So I'm going to have you practice the box method one more time on this next problem. So this is a factorable quadratic. Basically, you just rewrite it as x squared x constant. See if you guys can set up the box and factor it, and then your last step is you just make both of your x's x squareds instead. So it would be a bonus on the quiz as a quartic function, but this could be a quiz question, right? 5x squared minus 9x plus 4. See if you can do the box on that first. 5x minus 4 and x minus 1. So I got 20, right? And then, so you got negative 5x, negative 4x. So then I did 5x times x, but I have to get negative 5x here. So I did negative 1. And then x times negative 4x. So x, oh, this one could go further, couldn't it? So I actually didn't go far enough. This does not factor. 5x squared minus 4 gets stuck like that. But this actually should have factored into x plus 1, x minus 1 to be fully factored, because x squared minus 1 is actually the difference of 2 squares. So I would have lost points if that was a quiz question, because I didn't go far enough. If you did this on a bonus, I would be pretty ecstatic that you got this far, and I would still give you the bonus point. But if it's the test next Friday, it's got to look like this to be fully factored. Yeah. So there's